Algebra 2, Lesson 6-5, Solving Square Root and Other Radical Equations. A radical equation is an equation that has a variable in the radicand or has a variable with a rational exponent. I've given you 3 examples here. 3 plus the square root of x equals 10. That is a radical equation. X minus 2 raised to the 2/3 power equals 25. That's a radical equation. But the square root of 3 plus x equals 10 is not a radical equation because it doesn't have a variable in the radicand. It has a number in the radicand. A square root equation is a radical equation with an index of 2. Now, to solve radical equations, you isolate the radical on one side of the equation and then raise both sides of the equation to the same power. But be careful, sometimes when you do that, you introduce extraneous answers. So, if the nth root of x equals k, then the nth root of x to the n equals k to the n, and x equals k to the n. So, if I want to solve some square root equations, let's take a look at these first 2 here. I'm going to solve 2 plus the square root of 3x minus 2 equals 6. First thing I should do is isolate the radical all by itself, which means I need to get rid of this 2 here, so I'll subtract the 2 from both sides, and I will get the square root of 3x minus 2 equals 4. Now all I need to do is I need to get rid of the square root of 3x minus 2 by squaring both sides of my equation. When I square the square root, the square root cancels out the square, and the square cancels out the square root, so we end up with 3x minus 2 equals 16. Okay, now it's just a regular equation we just need to solve. So add 2, 3x equals 18, so x equals 6. So now we just need to check our answer to make sure that it's not extraneous. So I'm going to put 6 back into the original equation. So I have, I'm going to check it again for color here. I have 2 plus the square root of 3 times 6 minus 2. That's supposed to equal 6. Let's see if it does. So I have 2 plus 6 times 18. 18 minus 2 is 16. The square root of 16 is 4. 2 plus 4 does indeed equal 6. That checks. So our answer here of x equaling 6 is true, and it's not extraneous. Let's take a look at the second problem. X minus 5 equals the square root of x 18 minus 2x. So again, we will square both sides. We already isolated the radical on one side, so now we're just going to square both sides here. Remember, when you square x minus 5, it does not become x squared minus 25. You will have middle terms. Okay, just in case you don't remember, that would be x minus 5 times x minus 5, and that would be x squared minus 5x minus 5x plus 25, which is x squared minus 10x plus 25. You should be able to multiply those in your head by this time in your algebra career. Excuse me. So x, excuse me. X minus 5 quantity squared becomes x squared minus 10x plus 25, and that's going to equal 18 minus 2x. So, because we've got a squared term, we need to move everything to the left-hand side and set it equal to 0 and factor. So I'm going to add 2x, and I'm going to subtract 18. By doing that, this side becomes 0. Here I have x squared minus 8x. 25 minus 18 is 7. So now I'm going to look at x squared minus 8x plus 7 and see if I can factor that. So I need a product of 7 and the sum of negative 8. So I'm going to put negative 1 and negative 7. So x minus 7, x minus 1 equals 0. So x will equal 7 and 1. And I need to check both of these answers. Okay? They have to go back into the original problem, so I'm going to just rewrite my original problem down here so that I know what I'm supposed to be checking it into. The original problem was x minus 5 equals the square root of 18 minus 2x. And we have to check both 7 and 1. So I'm going to check 7 first. So I'll have 7 minus 5. Does that equal the square root of 18 minus 2 times 7? Well, 7 minus 5 is 2. Does that equal 18 minus 14, which is the square root of 4? And that does check, because that does 2 does equal the square root of 4. Now I'm going to check 1. So I'm going to have 1 minus 5. Does that equal the square root of 18 minus 2? Okay, negative 4. Okay, does that equal the square root of 16? Well, you might say, well, the square root of 16 is both positive and negative 4, but it's not, because we're only looking for principal square roots here. So this does not equal that. So 1 is not a solution in this particular case. So our only solution here is 7. Okay. To solve equations in the form of x to the m over n equals k, you're going to raise each side of the equation to the power of its reciprocal, n over m. Okay? If either m or n is even, then of course remember to put in your absolute value symbols. Okay? And that's going to come in critical in a couple of places. All right, so we have 6x plus 9 to the 1/3 minus 5 equals -2. So the first thing we have to do here is we have to get the variable by itself, the radical by itself, excuse me, which means I need to add 5 for both sides. So I now have 6x plus 9 to the 1/3 is equal to 3. Well, the reciprocal of 1/3 is 3 over 1. So I'm going to take 6x plus 9 to the 1/3 power, and I'm going to raise that to the 3 over 1 power, and that's going to equal 3 to the 3 over 1 power. These cancel each other out, so I basically have 6x plus 9 equals 3 to the 3rd power. Okay, so 6x plus 9 equals 27. Subtract 9, 6x equals 27 minus 9 is 18. Divide by 6. X equals 3. Okay. And of course, we should check it to make sure it's true. Right? So 6 times 3 is 18. 18 plus 9 is 27. The cube root of 27 is 3, so yes, it does check. Okay, so it works. Let's take a look at number 2 here. Now, number 2 is a little bit different. Okay. First of all, to isolate the variable, I'm going to divide both sides by 2. These will cancel, and I'll get x plus 3 to the 2/3 power equals 4. So I will have to raise this to the 3/2 power, which means I have to take this to the 3/2 power. Okay. So, now here's the important thing. It's a square root. It started out as a square root, because the 2/3 power means, it started out as a cube root, but now that we took the reciprocal of it to the 3/2 power, it becomes a square root. So we have to take it out of we have to take it out. This cancels this, but instead of becoming x plus 3, it becomes the absolute value of x plus 3, because we took an odd number out of an even root. Okay, so then this becomes 4 to the 3/2 power. Okay. So you might go, well, how in the world do you work with this? Well, first of all, the x plus 3 is in the absolute value symbol, so you know it's going to have to equal 2 different equations. You know that x plus 3 is going to equal 4 to the 3/2, and you know that x plus 3 is going to equal -4 to the 3/2. Sometimes it's easier to take it to the 3/2 power first before you take it to its negative, which is what I'm going to do, just because I think it's a little simpler because it's hard to follow that. So what I'm going to do here is I'm just going to keep my absolute value of x plus 3. This is 2 squared raised to the 3/2 power, so it becomes 2 cubed. So we have the absolute value of x plus 3 equals 2 cubed. And 2 cubed is 8. So we have x plus 3 will equal 8, and x plus 3 will equal -8, because we have the absolute value of it. And remember, the absolute value has to equal 2 things, the positive and the negative. So subtract 3 from both of those, and you'll get x equals 5 and x equals -11. And I'll save you the trouble and tell you that they both do check and it work. But the reason we needed to do that one, okay, because if we look at this first problem here, we took it to the 3rd power. We didn't have to worry about it. Okay, we had 3 over 1. Everything was odd. Okay, for this first problem where we had 6x plus 9 raised to the 1/3 power, and then we raised that to the 3 over 1 power, everything stayed odd. But over here, we had x plus 3 to the 2/3 power. We raised it to the 3/2 power. It became 6 over 6. Okay, so everything became even. And if we took 1x out of an even root, so we had to put the absolute value somewhere in there. All right. We've already done some checking for extraneous answers, but we're going to do some more. So we're going to check for extraneous solutions when we get these. So we have, what is the solution of the absolute value of the square root of 5x minus 1 plus 3 equals x? So I'm going to take 5x plus 5x minus 1 plus 3 equals x, and subtract 3. So I'm going to get the square root of 5x minus 1 is equal to x minus 3. I have to square both sides. 5x minus 1. Okay. No need for an absolute value because I'm just squaring it. Okay. And that's going to equal x minus 3 quantity squared is x squared minus 6x plus 9. Now I'm going to move everything over to the left, to the right hand side instead of equal to 0. So I'm going to subtract the 5x and I'm going to subtract the 1. Actually add a 1. And we'll get 0 equals x squared minus 11x plus 10. Okay, I will move this up here so that I can see it. X squared minus 11x plus 10. 0. Back to this. I need two numbers that multiply together to get 10 and add together to get negative 11, which is negative 10 and negative 1. So I'll get x minus 10 times x minus 1 equals 0. So x will equal 10 and 1. And of course, I need to check all of these again. Okay, if x equals 10, I would have the square root of 50 minus 1 plus 3 should equal 10. So that's the square root of 49, which is 7. 7 plus 3 does equal 10, so that checks. Let's check 1. So I would have the square root of 5 minus 1, which is 4. Plus 3 should equal 1. Square root of 4 is 2. 2 plus 3 does not equal 1, so that one doesn't work. Okay, so the only answer that works here is 10. Okay. If an equation contains two radical expressions, or two terms with rational exponents, isolate one of the radicals, or one of the terms, then eliminate it for its rational exponent, then isolate the okay, then you're going to have to isolate the other one. Isolate the more complicated radical expression first. In the resulting equation, simplify the expression before you eliminate the second radical. Okay, this is really important because these were fairly simple. Now we're going to get into some two more very complex problems. Okay, solving an equation with two radicals. Here I have the square root of 5x plus 4 minus the square root of x equals 4. I have two square roots. I can't have them both on the same side of the equation, so I have to move one to one side of the equation and one to the other side of the equation. So the first thing I'm going to do is I'm going to keep the square root of 5x plus 4 here. And that's going to equal the square root of x plus 4, or 4 plus the square root of x. It really doesn't matter. Okay, if you prefer it that way, you prefer it the other way, it doesn't matter. Okay, plus the square root of x, because it was negative here, so we added it. Okay. So now I can square both sides. Be careful when you square the right-hand side. Left-hand side squares really easily. It becomes 5x plus 4. Left-hand side does not square all that easily. Okay? Remember, it's an a squared plus b squared. So it becomes a squared plus 2ab plus b squared. So it's going to be 4 squared plus 2 times 4 times the square root of x plus the square root of x squared. Okay? Remember, if you can use those special products, you'll save yourself a lot of time. So we get 5x plus 4 equals 16 plus 4 times 2 is 8 square roots of x plus x. Okay. So now I need to simplify this because I still have a radical in my equation. So I need to get everything that does not have a radical to the other side. So I'm going to subtract my x and subtract my 16. So now I have 4x minus 12 equals 8 square roots of x. Now I have to square the equation again, because I still have to get rid of that radical. So I'm going to square both sides of my equation yet again. And remember, when you square both sides, okay, we're going to square an a squared minus b squared. Okay, so that's going to be a squared minus 2 times a times b, okay, plus b squared. And when we square 8 squares of x quantity squared, it becomes 8 squared times the square root of x squared. Okay, so to simplify this, you're going to get 16x squared. 4 times 2 is 8. 8 times 12 is 96. So negative 96x plus 144. 8 squared is 16, or 8 squared is 64. So we're going to get 64x squared here. This is square root of x squared of x. Sorry, not x squared of x. 64x. There we go. Now, I have to simplify and set everything equal to 0. So subtract 64x. How do I know that? Because I've got a quadratic equation. Okay, so now I have 16x squared minus 160x plus 144 equals 0. Okay, so I need to factor this. First thing I'm going to look for is the greatest common factor, because it's a lot faster. And I know that 16 goes into 16, I know it goes into 160. And it also goes into 144. And we take out a 16, I'm going to be left with x squared minus 10x, okay, plus 9 equals 0. So product and sum, I need a product of 9, sum of negative 10, which is going to be negative 9 and negative 1. And I have x minus 1, x minus 9 equals 0, because I can ignore this because it doesn't have a variable. So x equals 1 and 9. Okay? Now I have to check for extraneous answers. Yeah, if you get this far, and yes, you still have to check for extraneous answers. Back into the original equation, okay, which I will write down here. My original equation was 5x plus 4 minus the square root of x equals 4. So if I'm going to check 1, I'm going to have the square root of 5 plus 4 plus the square root of 1 is supposed to equal 4. So this is going to be 3 plus 1 equals 4. That one works because 5 plus 4 is 9, square root of 9 is 3. Square root of 1 is 1. Okay. Oops, not plus, it's minus. I changed one of my signs. Glad me. Okay, right here. 3 minus the square root of 1. So we're going to have 3 minus 1 equals 2. That does not equal 4. 4. So it doesn't work. So 1 does not work. Now let's check 9. We get the square root of 5 times 9 is 45. 45 plus 4 minus the square root of 9 is supposed to equal 4. Okay. 49 is 7. 7 minus 3 does equal 4, so that checks. So 9 works. If neither one of them checks out, then there's no solution. So don't get freaked out if none of them check. It just means there's no solution to that particular radical equation. All right, let's do another one. Yes, look how many steps that took. Lots of paper. I expect to see the same thing. All right, I better see all this lovely work when you do your problems. All right, the square root of 3x plus 3 plus the square root of x plus 2 equals 5. Okay, this one is actually even slightly harder than the last one. Okay, I'm going to move the square root of x plus 2 to the right-hand side. So I'm going to have the square root of 3x plus 3 will equal 5 minus the square root of x plus 2. Okay, square both sides. The left-hand side squares pretty easily, it just becomes 3x plus 3. The right-hand side, okay, it's going to become a squared minus b squared. So 5 squared minus 2 times 5 times the square root of x plus 2. Okay, plus the square root of x plus 2 squared. So you'll get 3x plus 3 equals 25 minus 10 square roots of x plus 2 plus x plus 2. Okay, so essentially, now let's simplify this as much as we can. So we're going to have 3x plus 3 equals 25 and 2 is 27. 27 minus 10 square root of x plus 2 plus x. So we need to get rid of the 27 and the x. We can't get rid of the 10 square root of 2. The 10 square root of x plus 2 because we still have as radical. So subtract the x, subtract the 27, and we will end up with, okay, now we're going to have 2x minus 24 equals negative 10 square roots of x plus 2. Now we got to square both sides again. Alright, so this becomes 2x quantity squared minus 2 times 2x times 24 plus 24 squared. And that's going to equal negative 10 squared times x plus 2. Because you just distribute that squared 10 into the x plus 2. Alright, so this gives us 4x squared. 24 times 4, okay, is 96. So 4x squared minus 96x plus 24 squared is 576. And that's going to equal negative 10 squared is 100 times x plus 2. So don't forget to distribute that. So you're going to get 4x squared minus 96x plus 576 is going to equal 100x plus 200. So now we move everything to the left-hand side so we can factor it. So subtract 100x and subtract 200. So we will get 4x squared minus 196x plus 376 equals 0. All right. Everything's divisible by 4, thank goodness. Take out my 4 on left. X squared negative 196 divided by 4 is negative 49. Negative 49x and 376 divided by 4 is 94. So now I need two numbers that multiply together to get 94 and add together to get negative 49. That would be negative 47 and negative 2. So x minus 47, x minus 2 equals 0. Negative x minus 2. Okay. And leave the 4 alone because there's a variable attached to it. So x will equal 47 and x equals 2. Okay. Let's check them. As much as you don't want to, we need to check them. So we'll check 47. Remember, it was the square root of 3x, so 3 times 47, 3x plus 3, plus the square root of x plus 2, so 47 plus 2. We're supposed to equal 5. Well, 47 times 3 is 140. 41 plus 3 is 144, so this becomes the square root of 144 plus the square root of 49. And I already know the square root of 49 is bigger than 5, so I can stop here because it's not going to equal 5. 12 plus 7 does not equal 5, so we know that 47 does not work. So let's check 2. So we have the square root of 3 times 2 plus 3 plus the square root of 2 plus 2 is supposed to equal 5. Well, let's take this down. So 3 and 2 is 6, 6 from 3 is 9, the square root of 9 plus the square root of 4 is then equal 5. You have 3 plus 2 equals 5, that checks. So 2 works. The biggest thing with these is making sure you don't make small errors along the way and making sure you understand how to multiply binomials. I warned you that multiplying binomials will come back to haunt you many, many times over. This is one of those examples.